Good morning, secondary 1. Here I will make a revision on unit 4. So please pay attention. There are very important questions. You will take 10 questions in chemistry subject in your exam. So please pay attention. This is a model exam, ministry model exam for the chemistry. It contains 10 questions. Okay, so please pay attention. Question number 1. Question number 1, choose the correct answer. If the temperature of half mole of pure water rises by 2 Celsius degree, so the quantity of heat in calories is, and these are the choose. Okay. Please pay attention here. In this question, he asks you about just half mole. So I will calculate the mass of 1 mole, then divided it by 2 to calculate the mass of half mole of pure water. And here I have delta T. Okay, and we know that the specific heat of water is a constant number, which is 4.18. Okay, so the steps here, quantity of heat, I can calculate the quantity of heat from this rule, QP, which means quantity under a constant pressure, equal the mass multiply specific heat multiply delta T, change in temperature. So the mass here will be 9. Pay attention. If I calculate the mass of 1 mole of water, which is H2O, the mass of 1 mole equal 18 gram. But he asks you about half mole. So I must divide 18 divided by 2. Okay, so the mass of half mole equal 9 here, multiply specific heat of water, which is constant number 4.18. Okay, multiply 2, which is delta T. The result will be 75.24 joule. And he asks you to calculate the quantity in calorie. To change from joule to calorie, I must divide the value by 4.18. So the answer here will be 18 calorie. The answer here will be 18 calorie. This is the first question. Let's go to see the second one. The system contains 2 substances, A and B. The change in energy for both of them as shown in the following table. The substance A, the change of energy negative 60, and the substance B, the change of energy positive 40. And he asks you about the change in energy for the surrounding. Pay attention here. I must calculate the total change of the system. So negative 60 plus 40 equal negative 20. So the change in energy for the system equal negative 20. This means that the system relays an amount of heat equal 20 kilojoule. Relays an amount of heat equal 20 kilojoule. And this means that the surround must gain this amount of heat, or this amount of energy, okay? Must gain or absorb this amount of heat energy. So the value of energy change in the surrounding will be positive, as the surrounding absorb the amount of heat energy, and will be by equal value, which is positive 20 kilojoule. Okay, again, the total change in energy for the system equal negative 20. Negative 20 means that the system relays an amount of heat energy for the surrounding by 20 kilojoule, and the surrounding absorbs this amount, so the value of a change in energy for the surrounding will be positive 20 kilojoule. Question number 3. The following table illustrates the specific heat for some elements in joule per gram Celsius degree. Aluminium 0.9, copper 0.38, iron 0.44, carbon 0.71. When equal masses of these elements are exposed to the same quantity of heat, the element whose temperature rises faster is, please pay attention. You must know what's meant by the specific heat. The specific heat is the amount of heat that I needed to raise up 1 gram of a substance by 1 Celsius degree. So, if the substance has a high specific heat, so it will take time to raise up its temperature. But if the substance has a low specific heat, so its temperature will rise faster. Okay? So which one its temperature rises faster here? The smallest value of specific heat, which is copper. The smallest value of specific heat is copper, so its temperature will rise faster. Okay? Okay. Question number 4. A system containing 5 grams of a substance A dissolved in 30 grams of water. In the end of the experiment, the temperature decreased by 3 Celsius degree and the mass of the solution was 35 grams for this system. What happens in this system? Pay attention. The mass doesn't change here, so there is no change in matter. I start with 5 grams for a substance dissolved in 30 grams of water, so the mass here will be 35. At the end of the experiment, the mass is still as it, 35 grams. So here there is no change in matter, but the temperature decreased by 3 Celsius degree. So the change here in temperature. I can conclude that the change here in energy, not in matter. And this will be closed system for sure. Question number 5. The temperature of 30 grams of platinum raised by 5 Celsius degree. If you know that the specific heat of platinum is 0.133 joule per gram Celsius degree, the amount of gained heat is, okay, here I need to calculate the quantity of heat. I will use this rule, QP equal mass multiply specific heat multiply delta T. Okay, so QP equal the mass of platinum 34 grams and the specific heat of platinum 0.133 and the delta T change in temperature raised by 5 Celsius degree, so delta T equal 5 Celsius degree, and the answer will be 22.6 joule. Okay, let's go to see another question. Here, question 6. Which of the following shapes express the right graphical relationship between the average of speed of molecule and the temperature? We know that by increasing the speed of anything, its temperature increase. So by increasing the average speed of molecule, the temperature of the substance must increase. So this is directly proportional. So the answer will be for sure shape C. Okay. Question number 7. Please pay attention. It's a very important question. 1 gram of hydrogen gas reacted as in the following reaction. H2 gas plus Cl2 gas producing 2HCl plus 185 kilojoule. Pay attention. The heat energy here in the product. So the heat energy released in this reaction, in the product, the heat energy in the product here, HCl and heat energy, which is 185. So this means that the heat energy in this reaction released. So my delta H will be negative value. So this is, yes, this is exothermic reaction. Exothermic reaction, as the heat produced from the energy, from the reaction. The heat is produced from the reaction. HCl plus 185 kilojoule. Okay, so I must choose my answer between shape C and shape D. C and D, as both of them are exothermic reaction from the diagram. Exothermic reaction. Okay, which one of them is the correct answer? Pay attention. In the equation, I have 2 grams of hydrogen, and this reaction release, so the value will be with negative, release an amount of heat energy equal 185 kilojoule. So 1 gram of hydrogen, he asks you about 1 gram of hydrogen. Pay attention. 1 gram of hydrogen release an amount of negative 92.5. What happens here? I divided 185 divided by 2 equal 92.5. Okay, so 1 gram produce negative, yes, produce, released, so it must be a negative sign, 92.5 kilojoule per mole. Okay, so the answer will be shape C. Question 8. The energy chart in the front of you express the following reaction. From the chart here, I can conclude that the reaction here is endothermic reaction. The reaction here is endothermic reaction. So the reactant absorb an amount of heat energy. Pay attention. In A, the reaction A plus B produce C plus 50 kilojoule, and this means that there is an amount of heat energy released. So this is exothermic, and this is not the correct answer. B, A plus B plus 50 kilojoule produce C, and this means that the system absorb plus 50 kilojoule. This means that the system absorb an amount of heat energy, and this is endothermic reaction, and this is the right answer. Pay attention. In C, A plus B minus 50 kilojoule. This means that the system release an amount of heat energy, and this is considered as exothermic reaction. And in D, A plus B produce C and delta H equal negative value, so this is exothermic reaction. So the only one that indicate the endothermic reaction is B, so the answer will be letter B. Okay. Question number 9. Pay attention. In the reaction, half H2 plus half I2 plus 26 kilojoule produce HI. The value of delta H of the following reaction. Pay attention. In the first equation, I can know that the value of delta H equal positive 26 kilojoule. How can I know that? Here I can find the value of delta H in the reactant, plus 26 kilojoule. So this reaction is endothermic reaction. The system absorbs an amount of heat energy equal 26 kilojoule. So the delta H here, yes, delta H is equal positive 26 kilojoule, and this is endothermic reaction. This is endothermic reaction. Okay, what about the value of the new equation here? Pay attention, the new equation here, there are many changes takes place in the new equation. Can you observe that the first equation, I have HI, hydrogen iodide, I have HI in the product, but in new equation I have HI in the reactant. So this is a reversing reaction. Okay, reversing reaction. So I must change the sign of delta H from positive to negative. So now delta H equal negative 26 kilojoule. But pay attention. In the first equation I have just 1 mole of HI. But in second equation I have 2 moles of HI. So I must multiply the value of delta H multiplied by 2. So negative 26 multiplied 2 equal negative 52 kilojoule. Okay. Let's see the last question. The following reaction, this is very important question, asks you about the bond energy, the average bond energy. The following reaction, H2 plus Br2 produce 2 HBr. And here in the table I have the value of the bond between H and H, between Br and Br, between H and Br. Firstly, you must draw your equation by structural way. So H2, the structure of H2, H bond H plus Br bond Br produce 2 H bond Br. Okay, when I calculate the bond energy equal, here I have 1 bond of HH. So the value of H bond H 436 plus, and I have just 1 bond between Br and Br, so plus 190. This is the value of Br bond plus, pay attention, plus here I have 2 bonds of HBr, but pay attention, HBr in product. So I must use the value of its bond energy in negative sign. So it will be 2 multiply negative 362 as it is in product. Pay attention, in bond energy, anything in product, I must put it in negative sign. The answer here will be negative 98 kilojoule per mole. So the answer will be letter D. Now I have finished my model exam. I hope all of you fine. So please pay attention and happy Ramadan. Thanks and goodbye.